Hello, my name is Carllnisha Bullard, and I'm coming to you today on behalf of the Danville Church-based tutorial program. Today, we will be working on adding and subtracting fractions and mixed numbers using an area model and context clues. Let's get started. First, let's review some vocabulary. Remember that our numerator is our top number, and it tells us how many parts of the whole are being considered. Our denominator is our bottom number, and it tells us how many equal parts the item is divided into. A mixed number is a number consisting of a whole number and a proper fraction. Our whole number in this example is 2, while our fraction is 1/3. Next, we have an improper fraction. With improper fractions, the numerator is greater than the denominator. We have 5/4. We have 1 and 1/4 if we were to change it to a mixed number. First, we're going to add 2/3 and 3/4. Now, we cannot just simply add these fractions because they do not have any numbers that are in common as far as our denominator. We have to have a rectangle or number that will represent both of our fractions. We need to make our fractions the same denomination. Using area models help us to see what we are thinking and help us to understand how each fraction relates to the other. First, you need to create a rectangle that is the same size for both of your fractions. Next, you need to partition or divide each of your rectangles into equal parts that match the denominators. The first area model needs to be divided either vertically or horizontally. This one will be divided vertically, which means up and down, while our second fraction we will divide horizontally, which means from left to right. You want to make sure you have divided your fractions into, or your rectangles into, equal pieces as much as you possibly can. And next we're going to shade in our amount for our numerators. And I'm going to do this by creating diagonal lines. And I'm going to go and choose a different color. So it's really helpful if you have two different colored pencils or a pencil and a color pencil. And we're going to choose a different color and shade in our rectangle or area model to represent our numerator. And here we have 2/3, so we need to shade in 2 pieces. All right, and with this fraction, we need to shade in 3 pieces because that's the amount that is being considered in our numerator. Next, we're going to use the denominator from the opposite fraction to divide our first fraction. So the denominator for 3/4 is fourths, so we're going to divide our 2/3 into fourths. Now you need to go horizontally to divide. Your first fraction. You want to do the opposite of what you did the first time. Okay, so now we have divided this into fourths, And as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts. We're going to do the same thing to our second fraction, except for this time we're going to divide it into thirds. You want to divide it into the denominator of the first fraction. And since we went horizontal the first time, this time we're going to go vertical or vertically. So we're going to divide this area model into thirds. And when you finish, you should have the same amount of pieces in each area model. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we have fractions that are represented by both of our fractions. So let's count how many pieces we have that are shaded. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 out of 12. And let's count our second one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 out of 12. 8 plus 9 is 17, and we keep the same denominator, which is 12. So we have 17 twelfths. If we divide 17 twelfths and turn it into a mixed number, we will have 1 and 5 twelfths, which is our final answer. Now we have 1 whole that has been shaded and 5 out of 12 that represents our answer. Next, we're going to subtract 2 and 2/5 from 1/2. Again, 2 and 2/5 is a mixed number, and 1/2 is just a proper fraction. We cannot subtract 2/5 from 1/2, so we need to create representations that will represent both fractions. All right, so we shade in 2 of our area models to represent our whole number, and then we're going to divide or subdivide this figure, the area model, for 2/5. So let's go ahead and divide it into fifths. Two, 3, and this last piece will be divided into fifths. All right, we divided this one vertically into fifths, and we're going to shade in 2 of those fifths, and we're going to use a different color. You want to just try to create some type of pattern where you can actually see how many pieces are shaded in. And we're going to do just like we did the last one. How many pieces should we divide this one into, this area model? Yes, we're going to divide it in half. And are we going to divide it vertically or horizontally? Horizontally, because we divided the last one vertically. Very good. And how many pieces should we shade in? We're going to shade in 1/2, 1 out of our 2 pieces. Again, we're trying to create area models that are going to represent both fractions. So we have to create fractions that have the same denomination. All right. Now, we're going to do the opposite to both of our area models. With 2/5, we're going to divide this in half horizontally. And with our halves, we're going to divide this into fifths vertically. And this is going to give us the same number of pieces for each area model. 2, 3, 4, and 5. You want to try to make them as equal as possible. All right, and let's count how many pieces we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Yes, and we have 4 out of our 10 that are shaded here. And 1, 2, 3, 4, 5 out of our 10 that are shaded here. So we have 2 and 2/5. I'm sorry, now we have 2 and 4/10 minus 5/10. Now, with 2 and 4/10, 5/10, we cannot just subtract them, even though they have common denominators, because 4 is greater than 5. And it's just like if we were subtracting something like 14 minus 9. And this is just an example. We cannot subtract 4 from 9 without having to borrow first. So we're going to do something similar with this fraction, with the mixed number and the fraction. We're going to borrow from the 2, and this is going to change into a 1, and we have to bring over 1 to 4/10, but we can't just simply add 1 to 4/10. We have to change it to a fraction since we're adding fractions together. And what's 1 as a fraction when speaking of tenths? Yes, it is 10 over 10, which is the same as 1. Now, we have to add these two fractions, which is going to give us 14 over 10. And now we can subtract this mixed number and fraction. So we're going to subtract 1 and 14/10 minus 5/10. We're going to bring our 1 down, and then we're going to subtract 14 from 5. And we already know we have the same denominator of 10. And our answer is 1 and 9/10. Here's one more example. We have 2/3 plus 4/9. Now, this one is going to be a little different because 9 is actually a multiple of 3. We're going to subdivide each area model like we would normally do. So I'm going to choose a different color. And I'm going to subdivide it into thirds using my denominator vertically. And I'm going to subdivide my second area model into ninths horizontally. Next, we're going to go ahead and shade in our area models according to our numerator. So I have 2/3 shaded, 2 out of 3 of the third shaded in for 2/3, and 4 out of 9 for the ninth shaded in. Next, you divide each area model into, you subdivide each area model according to the denominator of the other fraction. So for my thirds, I'm going to horizontally divide it into ninths, and for my ninths, I'm going to vertically divided into thirds. Now we have both of our area models that are representing both fractions. This gives us 18 out of 27 plus 12 out of 27. If we add those, we get 30 out of 27, or 30/27. If we turn that into a mixed number, we get 1 and 3/27. And when we simplify that, we get 1 and 1/9. An easier way to consider this problem would be just to simply divide 2/3 into ninths. So you end up with 6/9 plus 4/9. After you add 6/9 and 4/9, you get 10/9, which will turn into a mixed number and will give you 1 and 1/9. On behalf of the church-based tutorial program, we would like to thank the United Way and Danville, Pennsylvania County Foundation for their continued support.